Hello guys, welcome to AI Basic channel. So in this video, I'm going to discuss about mini batch gradient descent, how to do it from scratch in Python. So in the last video, we completed stochastic gradient descent, and in the before video, we completed gradient descent also. So in those videos, we done it very normal in simple way. But now in this today's tutorial, I'm going to take you to next level. That means here I'm increasing some difficulty level while creating our model. That means I'm including some classes and functions. We need to write some functions inside the classes. So now we are in the Jupyter notebook. So there is a small difference between stochastic gradient and mini batch gradient. In the stochastic gradient, we are updating the gradients after every each instance. But in this mini batch gradient, we are going to take the one batch from the dataset and we pass that to our model and we calculate the gradients. We update the gradients after every batch. So this helps us when we have large data set, so we don't run out of memory from our system. So we can overcome these problems. So I'm going to run these cells. Few cells are already written, just we need to implement the algorithm. So I kept some blank spaces here. These are the basic formulas required for this tutorial. So the first thing is I'm creating a class mini batch gradient descent. We created the class and inside we need to create some functions. Here I'm creating 4 functions. One is for creating batches and another one is for fitting our model, and third one is seeing the slope and intercept values, and the final one is for predicting the test values. So I'm creating function for create batch. Inside create function, we need to pass some parameters. Currently I am not keeping anything, just I am keeping pass. First we create the 4 functions. Next one is for fitting the model, fit pass, and third one is for visualizing the slope and intercept, slope intercept pass, and the final one is predict pass. So in our class we created 4 parts, 4 functions. One is create batch, and another one is fit, and third one is slope intercept, and the final one is predict. Before writing this code, I want to say something. So how we are dividing the batches? What is the process exactly is going on? For example, take in your dataset you have 100 examples, and you decided to divide those 100 examples into batches. For example, I want each batch contains 16 examples. Then I need to divide by 16. So based on that, I got 6 batches. Sometimes, like for example, see, sometimes here we got 6.25. So we are dividing 6 batches, and the another one batch is does not contain 16 examples exactly. So in our data set we have 7 batches. In 6 batches contains, each batch contains 16 examples, and the remaining batch contains less than 16 examples. That like that we have to take. So you get clarity how to create batch. So we need to fill this create batch function. First thing is I'm keeping some arguments, x train comma y train, and then another one is batch size. I'm removing pass. Okay, now we need to create one empty list. I'm calling as mini batches equal to empty list. And the next thing is we need to take that x train and y train and stack those things into one numpy array along the axis 1. Okay, I am creating a variable called data equal to np dot stack. Inside stack we need to pass our xtrain and ytrain, xtrain comma ytrain along the axis equal to 1. So I will show this thing how this data, how stack is working. So this is our data. This is called in the x-axis we have, I think in the x-axis we taken this number of years of experience. See 5.3 years of experience, and this salary is 8.300 into 10 power 4. Like that, this data is stacked into one numpy array. So the next thing is we need to shuffle the data before creating the batches. So np dot random dot shuffle. Inside we have to pass data. And the next thing is we have to store one variable. We have to store some data, like that means how many batches we are going to create. So number of batches equal to xtrain dot shape. This shape, yeah, the 0 contains number of our training instances in the training xtrain. Okay, so we need to divide it by batch size. And the next thing is we need to open one for loop for I in range number of batches. We opened a one for loop. Now we need to make the batches. Mini batch equal to in the data from I in, sorry, yeah, from I into batch size to I plus 1 into batch size. For example, batch size number is take 6. For example, take simple number, batch size is 4. Here I start from 0. So 0 into 4, 0. 0 to I plus 1 means 1. 1 into 4, 4. That means 0 to 4. It takes first 4 instances from the data. And we have to make that in a one batch. Okay, now we need to append this batch into mini batches. Mini batches dot append. In the append mini batch. So all instances in the mini batch, and contains means 4 instances in there. If we pass the 4 as a batch size, this is called x, and another one is we have to append another one also. I think we need to add another more parenthesis inside nest mini batch all comma 1. That means it takes the y variable. Okay, we completed our for loop. So the next thing is we have to make another batch with the remaining sample. That means if you have 100 examples, then we are going to divide into batches size as 16. So finally you will end up with one batch, last 7th batch. Few minutes back I shown that you example here. I think I removed that one. So you need to make another batch with the remaining instances. That instances are less than batch size. If xtrain dot shape equal to 0, sorry, divided by batch size not equal to 0, then we need to make another batch, final batch, this one, data I into batch size. That's all from batch size starting to ending onwards. Finally I am copying this line. Finally, you need to return the batches. Return mini batches. So we completed our first function, create batch. So let's check is that one is working or not. Let's mgd equal to mini. I think we have to run this before mini batch gradient descent mgd dot create batch x train comma y train comma batch size I am giving 2 because in our training examples we have only 22 instances, so I'm keeping it very small as a batch size. So now you got say 1.5 and 6. These are the years of experience, and here it is the salary. For example, now change the batch size into some to 5. See, in each example you have 5. For example, take 10. In each example you have 10 batches. I think we are missing the last batch. Sorry, in our code there is a small mistake is there. Here instead of divided you have to keep percentage symbol. That's why in the last time we end up some wrong batch. In the last batch we end up with wrong. Now it is getting correct. Just you need to change that thing into percentage. So here I set the batch size as 10. So here created two batches with 10 instances, and the last batch contains only 2 instances. That means we have 22 instances in our training dataset. It divided into 3 batches. First batch contains 10 instances, second batch contains 10, and third batch contains 2 instances. If you keep this batch size to 2, so you will get 10 batches. That's all you need to do for this create batches. Okay, next thing is we need to create our fit function. Okay, next I am removing this pass. First I am going to initialize the slope and intercept self.m equal to np dot. Here I'm not directly assigning the some random value with normally. Here I'm going to use some numpy random functions. Based on that I am assigning the m value initially. So this is helpful when you have more than one independent variable. Just you need to change one number for changing the number of independent variables. Let me show you that thing. np.random dot random. So here 1 comma 1, that means we have only one independent variable. If you have more than 2 independent variables, then you need to change 1 comma 2 like that. Okay, next thing is I'm initializing the slope also. Sub dot c equal to np dot random dot random 1 comma 1. Okay, we initialize the m and c values. Now I am taking length of strain also. Maybe this is helpful in further. Okay, next I'm opening first for loop. Sorry, one thing we need to pass some arguments, right? So self comma x train comma x test comma alpha comma and the epochs comma batch size. Here we are taking the batch size in the fit function. For I in range epochs. So now we need to retrieve the batches. I'm getting batches equal to self dot create batch. I'm passing the variables x train comma y train comma batch size. So it will return the batches. And the next thing is we need to iterate through batches for I in, sorry, for batch in batches. So here I am again dividing into xb and yb for simplicity. Xb equal to batch. In our batch, first one is contains xb values and the second one contains y values, equal to batch 1. Okay, now I'm reshaping the xb. So if we do not reshape, so we will end up with some dimension error. So I'm reshaping before passing into, before creating our model. Xb equal to xb dot reshape 1 comma xb dot shape 0. So it reshapes to 1 comma 22. So we don't end up with some dimensions error. Now we need to create the main algorithm. Intercept equal to, let's check the formula. Intercept means I think first one, predicted minus y actual summation of by divided by a number of training examples. Okay, here I'm using some numpy functions for summation the all instances in the one batch. So by using this numpy dot sum, we get rid of one for loop. np dot sum, inside again I'm opening another parenthesis. Next np dot self dot m comma xb plus self dot c minus y original c, predicted minus y actual divided by number of number of training examples. And here summation also you need to consider. This is the summation. So I'll divide when updating the gradients. I will divide this intercept when I updating the gradients. Next we need to create slope also. np dot sum np dot self dot m comma xb comma, so only xb plus self dot c and y minus yb. And I think we need to consider the parenthesis into xp. See here, y predicted minus y actual into x original, final summation, and it's finally divided by m. So now we need to update. So after every batch we are going to update. So now I need to update self dot m equal to self dot m minus alpha into intercept. I think this is slope, right? Slope divided by, sorry, L. L means total length of number of training examples. And finally we have to update self dot c equal to self dot c minus alpha into, so here intercept divided by L. So we completed our fit function also. Now next we need to fill this remaining function also. Removing pass, print f slope is self dot c 0, sorry self dot m 0, and again we need to open another inside, because this is a inside list inside. So next f and intercept is self dot c side 0 and another one. We completed our slope intercept viewing function also. Finally we need to fill the predict function also. Okay, let's complete it first. X test equal to, here I'm again reshaping the x test also. xtest dot reshape xtest dot shape 0 comma 1. Now we need to predicted value 1 minute before. I think we need to reshape the m also, so we don't end up with dimension errors. If you are confusing about reshape, try first trial the method. If you are getting any dimensions error, based on that you reshape that again. So I follow this order only. That's why it's very by we have to first trial and error method, then we have to set the exact dimensions reshaping. Self dot m dot reshape. Now I'm doing perfectly because I already done it before starting this tutorial. That's why I'm keeping these things. Self dot m dot shape 1 comma self dot m dot shape 0. Finally we need to calculate result equal to np dot xtest comma self dot m plus self dot c. Return result. Hooray, we completed our mini batch gradient algorithm. Now we need to find if this algorithm is working or not. I mean deleting this cell. We need to fit our model mgd dot fit xtrain comma ytrain comma alpha value 0.01 and number of epochs 4000 and the batch size is I am giving 4. We have some error. We got the error at stacking batches. Guys, we made another mistake. Let me show you that mistake. Here we are take the x test. So here we need to pass y train. Think okay. Here also we made another mistake, x train. But unfortunately we made that mistakes. Sorry for checking. Here I kept print hello before for cross checking. Okay, now our model works perfectly fine. Okay, next let's check our slope and those values. Slope intercept. Yeah, we got slope is 9669 and intercept is 25,235. Okay, let's see the plotting also. Oh, we forgot to predict the values. Y predict equal to min mgd dot predict x test. Sorry, we have to give any values. Yes, we need to pass the values, right? X test. Self is not defined. Where we use the self? Self dot m. Oh, here we wrote spelling mistake. Think self again. Where? Oh, inside we made self. Yeah, we got the perfect line. Now finally let's check our accuracy also. We got nearly 96% accuracy. Okay, let's change the batch size also. Let's check. Let's keep it to batch size 10. It is also working good. Batch size 10 also. If we keep the 1 means it becomes stochastic gradient descent. See, if you keep full training examples means it becomes gradient descent. So by using this model, you can use either if you want to make it either gradient descent or stochastic gradient descent or mini batch. You need to change the batch size. That's all. I'm keeping it to 4. Okay, finally we completed this tutorial. I hope you like this video. So you can expect 2 more videos on these regressions. I think next video is based on regularization techniques, and the next final video is on polynomial regression. So I think that is the end of this regression techniques. Next I jump into classification techniques. So in the classification techniques and take you to another level also. That means we are going to create one py file. In that py file we create this class and functions, and we import that py file into our Jupyter notebook, and we use that algorithm. Like similarly we are loading sklearn libraries, right? Like that we create our own py file and we load that py file and we use that py file. In those classification techniques we will do in that way. I hope you like this video, guys. Thank you. Don't forget to subscribe to my channel so you don't miss any latest technology updates on in AI, or if you want to learn machine learning from scratch, and if you want to learn TensorFlow also. I'm planning to start TensorFlow tutorials also after completing this machine learning series. Thank you, guys. I will see you in the next video.